Hello, my name is Rowan, and this is my screencast demo for my web-based penetration testing application. Inside this demo, we'll be looking at the web front end, a few back-end stuff, as well as how the tools are configured within this application. Right, so let's begin. So off the bat, we are looking at the home page, and each of the pages consisted in this application all derived from a layout, and this layout consists of a banner wrapper, which contains a logo and a login button, a navigation bar, which has CSS implemented transitions for depending on where the mouse is hovering. So in the navigation bar, we have a home, about, tools, and contact page, and also a content wrapper, which will hold all the content associated with the page. Now, for the first page we're looking at, home page, we are greeted with two cover photos, a header slogan, and a view tools button, which will redirect the user straight to the tools page. In the about page, we have an about header, as well as a brief description of what this web application is about, and a contact us page, which will direct the user straight to the contact page. Inside the tools page holds the technologies that the user can use to conduct penetration tests. These scanners are categorized in two areas, network and web server. And with these two buttons, it is JavaScript configured to perform a table fold and unfold accordion style. And for the purposes of this demo, we will be looking at the port scanner in the network section. And how all these tools are configured is that they each have their own individual HTML web page, HTML results page, and their own Python written file. So here in the port scanner, we are looking at the main port scanner HTML page. And with most of these web pages, we are consisted with a header, a small description of what the tool is about and how it can be used, as well as two post form fields where the user will input the appropriate information needed to run the port scanner function, which is in the port scanner Python written file. So for the port scanner, we are asked to provide an IP address and a port. For the port scanner, we don't directly need to put an IP address. We can put in even a host. So if I put in www.google.com and scan for port 443, port scanner will take that information and run it through the Python written file. As you can see, the results came fairly quick. Because google.com contains HTTPS, port 443 is open. Now, for the purposes of this demo, we'll try google.com again, and we will try a slower scanned port. In this case, we'll be looking at port 40. Now, because this is a much longer port to be scanned, I will cut this part out and be back to you when the results have come in. Now, the results just came back in. As you can see, port 40 is closed, and the time given for it is 21 seconds. Right, so that is the port scanner for our web-based penetration testing application. Next, we will be moving over to the web server category and be performing HTTP method testing on it. So similar to the port scanner, we are given a tool header as well as a brief description of what this tool is about and what is it used for. And similarly to port scanner, we are asked to provide a URL. Now for this tool, we need to provide the full URL. We can't just give it a host. So for that, we are going onto google.com and we're going to copy and paste the full URL into it. So if I press submit, and the results are back. Now what happens with this tool is that it basically requests the web server to see if these methods are available. As you can see, get method is available, but for the rest, they are not. So at the bottom of this results, we have a no sign for cross-site tracing. So if the trace method is not found or available in the web server, then there will not be a cross-site. There won't be any sign of cross-site tracing for this specific web server. So that's basically it for the front end. Next, we'll be looking at the back end. In the backend, the main framework used for this web application is the Python written micro framework Flask. And the reason why we use Flask is because it allows our application to import Python related libraries and functions for page routing, tool writing, and in our case, empty box checking. Now for the purposes of this video, we'll be looking at how Flask routes URLs to associated templates and a quick look at how the port scanner tool is utilized from the Python file, HTML and displayed onto the web application. Now, how Flask renders templates for your web application is that it implements this decorator called app.route and then has an associated / and then whatever name that you want to associate the URL with. So each URL that's associated with the decorator app.route has a function that is written right underneath it, which will be executed once this URL has been inputted. So in this case for home, if www.webapplication/home is inputted into the browser, it'll automatically run the associated function, which is to return a render template of home.html with the title home, so that it doesn't confuse it with any other web page. Now, how Flask works in order to find these HTML templates is that it uses a folder structure that determines the routing path the framework will utilize in order to find the right files. Now, there's a few basic structures that Flask utilizes, but in our case, I use the basic module structure, which starts off with the main parent directory, the repository, and within the repository it has your main Python files, a static file, and a templates file. Now, within the static file, you would contain your CSS directory with all your CSS style sheets, JavaScript, and images that you implemented into your web application. Now, inside my template page, I have a home HTML web page, which Flask will then find through the routing path, the single module routing path, and display it onto the associated URL. Now, that's how routing paths work with Flask in this framework. And the next thing we'll be looking at is how the port scanner is utilized and implemented through the Flask framework. Now, as I said before, each tool and technology has 3 separate files. It has its main HTML web page file, its results file, and its Python written function file. Now, for port scanner, if we look at the main HTML web page file, we see that there is a code block named extends layout.html. So basically what the extends code block does is that it allows for you to separate the unique code from the repeating code. So within the layout HTML, what we discussed before is that each page has its own individual layout. So when you implement a code block into the unique facing code, then whatever code that is before it, aka the layout, will be used as a repeating code. So that basically means I don't have to rewrite the whole layout.html again to display the web page in the format that I desire it to be. Now, within the port scanner.html web page, we have the title wrap, which we discussed before. This is the page header, the page definition and what it does, and here's the tool wrap itself, which contains the form. So what this basically does is that it performs an action which will directly send it to the HTML page process, which is connected to the results page. The method is a post method, so whatever information you put into the text fields will post the information out or the data out, and on submit return check for blank. Here you can see it says to provide any IP address, and the input is text. That is the input field for the IP address, and this is the input field for the port number. And then on submit, it'll take the information from here back to the main framework. And if we go under here towards port scanner underscore process, in the port scanner Python file, you can see that the function is written to take information called IP address and port number and then run it through the process here, which is to establish a socket. The socket basically determines the family and the kind of protocol that you want to use. In this case, it is an IPv4 protocol, and that we're listening out for open ports. So if it doesn't find a connection error, then if it does find a connection error, which is connect_ex, then it will return saying that the port is closed. If it doesn't find a connection error, then it will return saying that the port is open, and then it will it'll return the port number. So back here at the main framework, you can see that from the information that it pulls, it sends it into the function, and then we have a timer here to output the total time taken for the port to be scanned. So as previously said before, whatever associated URL has been input into the browser, it'll return the render template, which in our case is the port scanner results.html, because each tool does have its own results page, and it would also define and send information allocated to the variables. So data equals data, time equals final time. So data, whatever information, whether the port is open or closed, will be sent to this variable called data, and then be sent to the results page as the variable data. And time will have the final time, which is the total time estimate of how long the port was scanned. So over here on the port scanner results page, underneath the main template of the port scanner HTML page, we have a header called results over here with the output of the variable data and the output of the variable time, which we allocated back in the main web Python file. So with that, we looked at how the web frontend works, we looked at how the backend framework, and we looked at how the general outlook of how the tools are run and how they're implemented into the web application. That concludes the screencast and demo. Thank you for watching.